All right, we are now going to do a few practice problems using all of the information from video 1, where we talked about the focus and the directrix and how to get the equations and the point values for each of those, as well as discussing the transformations of parabolas. So our first example, we are in vertex form. Thank goodness, that makes life a little easier for us. We are going to graph it and from vertex form, state the transformations, and then answer each of these questions. So the first thing that we notice is that we have a negative in the very front. So that means that our graph is going to reflect. So if this is a y equals equation, I know it has to open up or down. And because the a value is a -2, I know that my graph has to open down. So that's the reflection part. So we can actually answer that a little bit as well. So this graph will open down. I already have just a brief picture of what my graph should look like. The actual 2, that's of the -2, because this is vertical, this will be a vertical stretch of 2. So our graph should be nice and tall and skinny. And then we have the x minus 1 in parentheses. This is going to be the h coordinate of our vertex. So we are going to travel to the right 1 unit. And last but not least, our k value at the back end is +3. So that is going to tell us that we need to travel up 3 units. So instead of starting at the origin, we are going to travel to the right 3, and I'm sorry, to the right 1 and up 3 units so that we can put our vertex right here at the point 1, 3. There we go, 1, 3. Okay, our axis of symmetry, because it is vertical, has to be a vertical line, so it has to be x equals, and it's always going to be that h value of your vertex. So we will draw just very lightly that dotted line that cuts our graph in half. Okay. In order to continue with our graph, the a value that we have in the front, for a parabola, there is a pattern that follows anytime you want to plot some points. You can use your calculator to get points. You can substitute a couple of points to the right and to the left of your vertex. So like if you wanted to create yourself a table, I would choose the points -1 and 0 as some x values to substitute, and then I would also choose +2 and +3. So I'm picking 2 points to the left and 2 points to the right. You can also just one time and one time only use your a value, which is -2, and you can treat it like you would treat slope, which would be -2 over 1. So from our vertex, we can drop down 2 and go to the right 1 and put a point, and that would give us a point to the right of our vertex, and we can mimic that on the opposite side of our axis of symmetry, down 2 and to the left 1. Okay, so if I were to substitute a 0 in the equation, I should get the point 0, 1. If I were supposed to substitute a 2 into the equation for the x, I should also get the point 2, 1. Okay, and if you were to follow the other points, you could do that. We're just rough sketching it right now, passing through those points. So my x-intercepts are not going to be precise, but you kind of get the idea of what they're going to look like. Okay. The next thing that we need to do is determine our p-value so that we can in turn remember the p-value is equidistant from the vertex to the focus as well as your directrix. So we're going to use our p-value and determine what that is to figure out how far we're going to travel, in this case, up and down from the vertex in order to place our focus at its precise point and our directrix, that line where it needs to go. So for p, we're going to say a equals 1 over 4p. I know my a value, that leading coefficient, is -2, so -2 equals 1 over 4p. And if I were to cross multiply and solve, I would get -8p equals 1, so my p-value is -1/8. The negative tells you the direction to go to plot the focus point. Okay, so what that is telling me is from the vertex, I need to go down, in this case, because it's a vertical one, 1/8 so that I can plot my my focus point. So what we're going to do is we're going to take the vertex that we have, which is 1, 3, and I'm going to take 3 and I'm going to subtract 1/8 from it to determine our new coordinate for the focus. So 3 minus 1/8 is 2 7/8. And you can write that as the mixed number, or you can change it to an improper fraction. I'm just going to keep it as a mixed number. So 1, 2 7/8. So just a little bit below the vertex is where my focus is going to be. Now that's just to get our focus. We need to do the exact opposite to get our directrix. So we're still going to use that K value, or the back end of our vertex, and in this case we need to add 1/8 because we need to go above our parabola, and we need to sketch our horizontal dotted line 1/8 above the vertex. So I'm going to add 1/8 to the 3, and I'll write my equation y equals 3 1/8. Again, you can change that to a mixed number. That can be 25/8 if you'd rather it be that way. That's everything you need. Good job on your first one. This is vertical with our new 2 pieces of discussing the focus and the directrix. All right, example 2, we have y equals the quantity of x plus 2 squared and then minus 6. So we are first going to describe our transformations. Our a value that we have in the front is just +1, so there's no vertical stretch, no shrink, and it does not flip upside down. So since it is a y equals equation, I know it has to open up or open down, and because my a value is positive, our graph is definitely going to open up. There we go. So I already have a rough idea of what my graph should look like. Inside parentheses, we have x plus 2. So if I have x plus 2, I'm going to do the opposite of that, and we're going to travel to the left 2 units. And the minus 6 at the back end outside parentheses tells me that I need to travel down 6 units. So in order to plot our vertex, we have to go to the left 2 and down 6 from the origin. So we're going to be at the point -2, -6, and there is your vertex. Our axis of symmetry has to be that vertical line that passes directly through the vertex. So since it's a vertical line passing through, we're just roughly going to very lightly sketch that dotted line, and that happens at x equals -2. Again, we are going to use our a value in the front, which is +1, and we're going to help us use that in order to get some points. Remember, you can use it one time and one time only. If I wanted to choose points, I would choose 2 points to the left of -2, so I would do -4 and -3, as well as 2 points to the right of -2, which would be -1 and 0. And when we substitute in a -3 for x and a -1 for x, I should end up with a y value of -5, because our rate of change in the first set of points is 1, so I'll travel up 1 to the right 1, mimic that on the other side of your axis of symmetry so that you can do a rough sketch of your parabola. And that one opens up, vertex at -2, -6, and our other points are 1 unit away. Okay, the next thing that we need to do is determine our focus and our directrix. And remember, we are using our p value, or excuse me, we're using our a value, setting it equal to 1/4p so we can solve for p. That tells us our distance. If a is 1, then 1 will equal 1/4p. Again, we'll cross multiply 4p to equal 1. And p is 1/4. Again, the positive tells us that we are going to either move up or to the right, in this case up from the vertex so that we can plot our focus 1/4 above. So I am going to add the p-value to the k, or the y-coordinate of my vertex, so that I can determine my focus. So my focus is going to be -2, comma, and then I want to do -6 plus 1/4, which would give me -5 3/4. And again, that's to get our focus. If I want to determine the directrix, I need to do -6 minus 1/4, because I'm going to travel outside the parabola and I will be 1/4 below the vertex to create my directrix. And that is a horizontal line, so that'll be y equals -6 minus 1/4 would be -6 1/4, or -25/4. There you go. This has been kind of long. We're going to spend probably another 10 minutes on the next 2 examples, so just stick with me. These are horizontal, and these are the ones that are completely different than what you've done. You haven't graphed these before. Technically, a horizontal parabola would not be considered a function, because if a parabola sits on its side, whether it opens to the left or the right doesn't matter. If you draw a vertical line through it, it's going to pass more than one point, but we still graph them as conic sections. Okay, so we're going to go through, describe our transformations. Our a value in the front, the 2, tells us that we will have a stretch, and in this case it would be a horizontal stretch, so we're going to make it nice and skinny going out to the left or to the right. We have y minus 5 in parentheses, so we're going to do the opposite of what this says, and it's with the y value, so that means in this case we're going to go up 5. The plus 7 on the outside would be the h value of your vertex, and that tells me that we are going to travel to the right 7. So if it's in parentheses, you change it. If it's outside parentheses, you keep it the same. So our vertex in this case is the 0.75. Now I'm going to go ahead and tell you, that's usually the first goofy mistake that the majority of us make, because we're just so used to doing them the other direction. So be really, really careful. Know that you have a horizontal parabola, and you've got to get your h from the outside and your k value from inside your parentheses. Okay. Our axis of symmetry is going to, we do know that this one's horizontal. It's going to open to the left or right. If our a value is positive, we are going to open to the right. So let's go ahead and get ourselves squared away with that. So I'm going to draw my axis of symmetry through the vertex going horizontally. So that is going to be with the y value of your vertex. So our axis of symmetry is going to be y equals 5. Okay, we do get to use our a value, but we're going to use it a little bit differently. Because this is a horizontal stretch, we're actually, you can kind of think about flipping the slope. So if our a value is 2, we normally would go up 2 to the right 1, up 2 to the right 1, that kind of thing. But we're going to flip it, okay? So we're going to actually travel to the right 2, and then up 1, and to the right 2, and then down 1 to mimic those 2 points so that we can sketch our graph. Another way you could think about it is, well, there's a couple of different ways. You could, in your mind, change it so that your slope is the reciprocal. You could write it as 1/2. So you would know, oh, I can go up 1/2, down 1/2. Or if you're visual, turn your head to the side, turn it to the right, and look at your graph and go, oh, if my slope was 2, I would go up 2 and out to the sides 1. So you can do it that way as well. A couple weird things on that guy. Next thing, we need to determine our p-value so we can get our focus and our directrix. Remember, our focus is always going to use our vertex. So we are, in this case, we're going to add our p-value to the h coordinate. So the 7 is the part that's going to change, and we'll subtract our p-value from the h coordinate so that we can get our directrix. So here we go with the p-value. A equals 1 over 4p, or 2 equals 1 over 4p. Cross multiply, 8p equals 1, and p is 1/8. Again, that positive tells me I'm going to travel to the right so that I can plot the focus first. So my focus will be to the right of my vertex. So I need to take my 7 and add the 1/8 to it. So our focus point is going to be 7 and 1/8, comma 5. Okay. The directrix has to be on the outside. In this case, it will end up being on the left-hand side of the vertex, so we need to subtract the p-value. So we're going to take our h value, which is 7, and subtract 1/8 to give me 6 and 7/8, and that's a vertical line. So it will be x equals 6 and 7/8. Again, change those if you want them to be improper fractions. Great job, guys. I know that one was a little bit funky the first time out. Let's try one more and then we'll be done with this lesson. So last example, x equals negative times the quantity of y minus 2 squared plus 5. This definitely sits on its side. It is in fact horizontal because it is an x equals. Since my a value is -1, I need to flip my graph to face the other direction. So this one is going to open to the left. To help us get our vertex, that y minus 2, remember that's in parentheses, we're going to do the opposite of what's there. So we're actually going to travel up 2 because it's with the y. My k value is in parentheses. And the plus 5 on the back end, that's the h value of the vertex. Do exactly as it says. That guy says to go to the right 5 units. So from the origin, we are going to travel to the right 5 and up 2 and plot our vertex. We know it opens to the left, so I kind of give myself a little idea, hey, it's going to go to the left this direction. So therefore my axis of symmetry has to cut right through the vertex in a horizontal line. So we are going to use the 2 from our vertex. We're going to use that y coordinate, y equals 2 for the AOS. Okay. Again, our a value was -1, so this one we are going to move to the left 1 and up 1, to the left 1 and down 1. And again, you can determine your pattern, or you can use your table to get yourself some other points. It would be easier for you just to kind of figure those in yourself, like actually substitute different y values for those guys. Let's determine our p value so I know where to put my focus and the directrix. A is -1. That will equal 1 over 4p. And when I cross multiply, I get -4p to equal +1. So p will equal -1/4. So I'm going to travel to the left first to get the focus. So my focus is going to be to the left, which means I need to, in this case, subtract p from the h coordinate of your vertex. So my vertex is 5, 2. I need to do 5 minus 1/4. So that gives me a focus point of 4 3/4, comma 2. To get my directrix on the outside, it's going to be to the right of the vertex. So you need to add the p value to the h coordinate of your vertex. So that's going to be 5 plus 1/4, or 5 1/4, and we drew a vertical line, so that will be x equals. And that's it.